Oh no, you need to know logarithmic differentiation and the math finals tomorrow. What will you ever do? Well, don't fret, because Professor Cat and I will explain to you all about it in this crash course. So, what is logarithmic differentiation? So, logarithmic differentiation is a technique used when you need to take the derivative of a function where there's a variable in both the base and exponent of said function. For example, let's take a look at the equation y equals x to the power of 3x. In this equation, there is a variable in both the base and exponent, the base being x, while the exponent is 3x. Thus, we have to use logarithmic differentiation if we want to solve for the derivative. Okay, so now that we know what logarithmic differentiation is, how do we solve logarithmic differentiation questions? Let's start off by taking a look at a simple function. Let's look at the function y equals x to the power of x. In this case, we have to use logarithmic differentiation because there is both a variable in the base and exponent, both of which is x. You may be tempted to try to use the power rule in this case, but you cannot use the power rule as the power rule only works if the exponent in the function is a constant, in which this case it is not, since it is x, which is a variable. Instead, to separate the variable in the exponent from the variable in the base, we will be taking the natural log of both sides, which is step 1. When we take the natural log of both sides, we're going to end up with the equation of the natural log of y equals the natural log of x to the power of x. But because of log rules, we know that the natural log of an exponential expression equals the product of the exponent of that expression times the natural log of the base. So the natural log of x to the power of x equals x times the natural log of x. Thus, we end up with the natural log of y equaling x times the natural log of x. Now let's move on to step 2, where we use implicit derivation to find dy dx. Before we go any further, let's just do a quick refresher on how to do the derivative of the natural log and using the product rule. So the derivative of the natural log of x is equal to 1 over x, while the product rule is the derivative of the first times the second plus the derivative of the second times the first. Once we do this, we get dy dx times 1 over y equals x times 1 over x plus the natural log of x times 1. Now let's move on to step 3, where we have to isolate dy dx and simplify. So now that we have this expression, let's move y to the other side of the equation and cancel out the x's in the first term. So that way we can get dy dx equals y times 1 plus the natural log of x. So now the final step, step number 4, is to substitute y and then simplify. So if you remember from the original equation, we know that y equals x to the power of x. Thus, let's just plug that in back to our derivative, and then we get dy over dx equals x to the power of x times 1 plus the natural log of x. That's it. You're finished. Great job, guys. We did it. Yeah! However, if you still don't feel like you quite get it, or you just want some more practice, I have 2 more practice problems that we will go over. Okay, so pause here and practice these 2 questions by yourself. But remember, don't forget the chain rule. Okay, now let's go over question number 1. So we have the equation y equals x to the power of 3x. So the first step is to take the natural log of both sides and to make the right side into a product. So for step 1, we get the natural log of y equals 3x times the natural log of x, because 3x was the exponent of x. So let's move on to step 2 and use implicit differentiation. So we get dy dx times 1 over y equals 3x times 1 over x plus the natural log of x times 3. So now for step 3, let's isolate dy dx by multiplying both sides of the equation by y, and then simplifying the expression on the right side. So for the first term, we can cancel out the x's to just get 3. And then we put it all into one expression where it becomes 3 plus 3, the natural log of x. And that whole thing is multiplied by y. So we get dy dx equals y times 3 plus 3 times the natural log of x. So now let's move on to our last and final step, step 4, where we just replace y with the original expression, x to the power of 3x, and thus we get dy dx equals x to the power of 3x times 3 plus 3, the natural log of x. So now let's move on to the second question. So just like the other one, we're going to start off the exact same way. We're going to take the natural log of both sides of the equation, and then we're going to make it into a product. So we get the natural log of y equals cosine of x times the natural log of sine of x. So just like before, for step 2, we're going to use implicit differentiation, and we're going to get dy dx times 1 over y equals cos of x times cos of x over sine of x plus the natural log of sine of x times negative sine x. But wait a minute. I told you that the derivative of the natural log of x was 1 over x. So how did I get cos x over sine x? And now this is where the chain rule comes into play. So let's take a step back for a second so I can explain to you how to take the derivative of the natural log of sine x. So the formula that I gave you before wasn't wrong. It was only used if what's inside the natural log is just the variable of x itself, because that assumes we don't have to use the chain rule. So here's a more generalized version of the exact same expression. In this case, when we take dy of dx for the expression the natural log of u equals 1 over u times a derivative of u itself. So to employ it for this example, we set u to be equal to sine of x. Thus, we get the derivative of the natural log of sine x equals cos of x which is because it's u prime, times 1 over sine of x, and then that gets simplified to cos of x over sine of x. So now let's head back into the question. So just like before, for step 3, we're going to isolate dy dx and simplify what we had on the right. So once we do that, we get dy dx equals y times cos squared of x divided by sine of x minus sine of x times the natural log of sine of x. And then once again, our final step is to just substitute y for the original expression. So then we get sine of x to the power of cos of x times cos squared of x over sine of x minus sine of x times the natural log of sine of x. Thank you so much for watching. I really hope this helped you out today. Good luck studying. See you next time.